training session on building a real-time chat application using FastAPI and Angular. In this session, we'll guide you through each step to create a functional chat app, from setting up your environment to running the application. Let's get started. First, we'll set up our development environment. We'll begin by setting up a Python environment using Anaconda. Anaconda is a powerful platform that simplifies package management and deployment. It includes a large collection of pre-installed packages and tools, making it easier to set up your Python environment. In this tutorial, we assume that Anaconda is already installed on your machine. First, open the Anaconda prompt. You can find it in your Start menu on Windows or open a terminal if you're on Mac OS or Linux. For convenience, I have pinned Anaconda prompt to the taskbar on my Windows PC, so I'll click on it to open. To create a new virtual environment, use the conda create command followed by the name of the environment and the Python version you want to use. In this example, we'll create an environment named myenv with Python 3.11. Conda will resolve the dependencies and ask for confirmation. Type Y and press Enter to proceed. Once the environment is created, activate it using the conda activate command followed by the environment name. This command switches your session to the new environment. You'll notice the command prompt changes to show the name of the active environment. Next, let's install the necessary packages for FastAPI. FastAPI is the web framework we'll use, and Unicorn is the ASGI server to run our FastAPI application. Install both by typing pip install FastAPI Unicorn. Press Enter and wait for the installation to complete. Create a new directory for your project. FastAPI-chat. Then, move into the new directory by typing cd FastAPI chat. Now that we've set up our FastAPI environment, let's open our project folder in Visual Studio Code. It's quick and easy. Once you're in your project directory, simply type code. That's code followed by a space and a period. Press Enter, and Visual Studio Code will open with your project folder loaded. And there you have it. Your project is now open in Visual Studio Code, ready for you to start coding. Create a new file named main.py in your project directory. To start, let's create a simple FastAPI application to verify that the FastAPI and Python environment have been set up correctly. First, we start by importing the FastAPI class from the FastAPI module. This import brings in all the tools we need to create our FastAPI application. Next, we create an instance of the FastAPI class and store it in a variable named app. This app instance will be our main application, where we'll define our routes and handlers. Now, let's define a route. Using the @app.getDecorator, we tell FastAPI that this function should handle GET requests to the root URL, represented by a single slash. We then define a function named readRoot. This function will be called whenever a GET request is made to the root URL. Inside the function, we return a simple JSON response. When someone visits the root URL, they'll receive this JSON message. And that's it. You've just created a basic FastAPI application. This example sets up a simple web server that responds with a friendly message when accessed. Now, let's learn how to run your FastAPI application using UVcorn. In your terminal or Anaconda prompt, make sure you're in your project directory. Then, type the command UVcorn main:\app -reload. Let's break this down. The command UVcorn is used to run the UVcorn server, which is an ASGI server for Python web applications. Next, main:\app specifies the application to run. Here, main refers to the name of the Python file containing your FastAPI app, and app refers to the FastAPI instance within that file. So, if your file is named main.py and your FastAPI instance is called app, this part of the command tells UVcorn exactly what to run. Finally, the -reload flag is used to enable auto-reloading. This means that UVcorn will automatically restart the server whenever you make changes to your code. It's a great feature for development because it allows you to see your changes instantly without having to manually restart the server. After typing the command, press Enter. UVcorn will start the server, and your FastAPI application will be running and ready to use. You can now open your browser and go to localhost port 8000 to see your application in action. And that's it. You've successfully started your FastAPI application using UVcorn with auto-reloading enabled. Next, we'll update our FastAPI application to include WebSocket functionality and cross-origin resource sharing, or CORS middleware. First, we import the necessary modules from FastAPI. These imports bring in FastAPI, WebSocket support, CORS middleware, and type hinting for lists. Next, we define a connection manager class to manage WebSocket connections. This class keeps track of active connections and provides methods to connect, disconnect, send personal messages, and broadcast messages to all connections. First, we define the connection manager class. This class will manage all WebSocket connections, allowing us to handle connections, disconnections, and message broadcasting. Next, we initialize the class with a constructor method in it. Here, we create an empty list called active connections to keep track of all active WebSocket connections. The type hint list of WebSocket indicates that this list will contain WebSocket objects. Now, let's look at the connect method. This asynchronous method takes a WebSocket object as an argument. When a new WebSocket connection is established, we call await WebSocket.accept to accept the connection, and then add the WebSocket object to our active connections list. Next, we have the disconnect method. This method removes a WebSocket object from the active connections list. It's called when a WebSocket connection is closed or disconnected. Let's move on to the send_personal_message method. This asynchronous method sends a personal message to a specific WebSocket connection. It takes a message string and a WebSocket object as arguments, Then uses await WebSocket.send text message to send the message to that WebSocket. Finally, we have the broadcast method. This asynchronous method broadcasts a message to all active WebSocket connections. It takes a message string as an argument and iterates over each WebSocket in the active connections list, sending the message to each one using await connection.send text message. And that's the Connection Manager class. This class provides essential methods for managing WebSocket connections, handling new connections, disconnections, and sending messages both personally and to all connected clients. We create an instance of Connection Manager and store it in a variable named Manager. Finally, we define a WebSocket endpoint using the @app.WebSocket decorator. This endpoint listens for WebSocket connections at /ws/chat. When a client connects, it adds the connection to the manager. It then enters a loop to receive messages from the client and broadcast them to all connected clients. If the client disconnects, the connection is removed from the manager. We then define a list of allowed origins for CORS. Here, we're allowing requests from localhost port 4200. We add the CORS middleware to our FastAPI app. This middleware enables cross-origin requests from the specified origins and allows credentials, all methods, and all headers. And there you have it. This FastAPI application sets up a WebSocket server with CORS enabled, allowing real-time communication between clients. Next, we're going to learn how to test a WebSocket API using Postman. Our WebSocket server is implemented with FastAPI and is running locally. The server address is localhost port 8000 and the WebSocket endpoint is ws/chat. Let's dive into the step-by-step process. First, ensure that you have Postman installed on your computer. Open Postman and let's get started. In Postman, click on the New button located in the top left corner. A pop-up will appear with several options. Select WebSocket Request. This will open a new tab dedicated to WebSocket testing. Now, in the request URL field at the top, you'll need to enter the WebSocket endpoint you want to test. Since our FastAPI server is running locally, the URL will be ws://localhost port 8000/ws/chat. This URL points to our WebSocket endpoint. Click on the Connect button next to the URL field. Postman will attempt to establish a connection with the WebSocket server. If successful, you'll see a status message indicating that the connection is open. Once connected, you can start sending messages to the WebSocket server. In the message field at the bottom, type your message. For our example, type "Hello, FastAPI WebSocket" and click the Send button. The message will be sent to the server. After sending a message, the WebSocket server will respond. In this example, you'll see the response in the Messages section. This real-time interaction is a key feature of WebSockets, allowing for continuous communication without re-establishing a connection. When you're done testing, you can close the WebSocket connection. Simply click the Disconnect button. This will terminate the connection with the WebSocket server. And that's it. You've learned how to test a WebSocket API using Postman with FastAPI running locally. This process allows you to ensure that your WebSocket communication is functioning correctly. And that brings us to the end of part 1 of the session. Let's recap what we've covered. We started by learning how to create a FastAPI backend application. We then implemented WebSocket functionality to accept connections and send personalized or broadcast messages. In the part 2 of the session, we'll take this further by implementing a simple front-end in Angular. You'll learn how to send and receive chat messages through our WebSocket API, completing the full cycle of a real-time chat application. Thank you for joining us today. Don't forget to like, share, and subscribe to stay updated on our latest content. See you next time.